Lesson 90, adding and subtracting rational expressions. Let's just start with an example. We're going to add 7y divided by 4y squared plus 3y divided by 4y squared. Because the denominators are the same, we can add the numerators and keep the denominator 4y squared. So 7y plus 3y is 10y. Then we're going to reduce to 5 divided by 2y. Here's another example. If we have 2k squared divided by k squared plus 5k minus 24, and we're going to take away 6k divided by k squared plus 5k minus 24. So since the denominator is the same, we're going to go ahead and subtract, and we have 2k squared minus 6k. Now what we want to do is factor both the numerator and the denominator to see if we can cancel. So in the numerator we can take out a 2k, and we're left with k minus 3. Then if we're going to factor this, we have k. We need to think of two factors of negative 24. That gives me a positive 5. How about 8 times negative 3? 8 times negative 3 is negative 24. 8 plus negative 3 is 5. So we're going to do plus 8 minus 3. Then we can cancel the k minus 3, and we're left with 2k divided by k plus 8. And that's the simplified form. Okay, here's another example where we do not have common denominators, and we're going to have to get a common denominator. So we have 1 divided by 5k cubed plus 4k divided by 10k. Okay, so let's see. I'm going to simplify this fraction before we go on. So the k's cancel. 4 divided by 2 is 2. 10 divided by 2 is 5. So we have 1 over 5k cubed plus 2 fifths. Now I need a common denominator of 5k cubed. So I'm going to multiply the second one by k cubed over k cubed. So I have 1 over 5k cubed plus 2k cubed over 5k cubed. Now we don't want to cancel here because we have a common denominator. We're just going to leave our denominator the same and add 1 plus 2k cubed. And this will be our final answer because we can't simplify that anymore. Here's another example. We have x plus 3 divided by x minus 1. And we're going to subtract x plus 5, whoops, I put that in parentheses, divided by x squared plus 8x minus 9. So let's rewrite our fractions. In the second one, I would like to factor, and we have x plus 9x minus 1. So wait, that gives us a negative 9. 9 minus 1 is 8. Okay. So notice that this one has an x to the minus 1. We need it to have an x plus 9 also. So I'm going to multiply these. There, now we have a common denominator, and we're going to have to subtract. So let me multiply these first. We get x squared plus 9x plus 3x, so plus 12x plus 9 times 3 is 27 over x plus 9, x minus 1, minus x plus 5 divided by x plus 9, x minus 1. Now, when I subtract, I have to remember to distribute the negative sign. So this is what I get. Let's see. I have x squared plus 12x minus x is plus 11x. Then I have plus 27 minus 5 is plus 22 divided by x plus 9, x minus 1. So let me see, can we factor 22, 11 times 2? No, we can't factor the numerator, so this is our final answer. Okay, one more example I want to do for you guys. So example 5. We have 6 divided by a minus 3 plus 4a divided by 3 minus a. Whenever you have a subtraction sign and the two numbers are switched, all you have to do is times one of them, I'll just do the first one, by negative 1 over negative 1. So now we have a negative 6 divided by negative a plus 3 plus 4a over 3 minus a. Notice now the denominators are the same. They're just switched order. So we're going to keep it 3 minus a, and we have negative 6 plus 4a, which I'm going to take out, let's see, can I take out a negative 2? So if I take out a negative 2, I'm left with 3 minus 2a, all divided by 3 minus a. I can't cancel anything, so this is my final answer. And that's the end of the lesson.